Okay, here we are with the next chunk O problems for chapter 2 that we'll be able to finish it in this little time period. We're going to start off with 61. And for these last problems here, it's more about kind of like the naming process. That was a big chunk of chapter 2. Given these different names, we already have the names, we're going to write out the formulas for them. And we went through the process within chapter 2 in the lecture portion how to actually go through this. So the first one here, we're looking at chlorite ion. And just to refresh how these names go, whichever one of the oxyanions is most common, that one gets the ending ate. And in this particular case, you just have to memorize it. There's not some way around it. This one happens to be ClO3 1 minus, and they all are 1 minus for these chlorine oxyions. Okay, anything that has one less, or if the compound, the chlorine compound has one less, that gets the ite name. Therefore, for A, we're looking at chlorite ion. That's ClO2 1 minus. And then if we do B, we're looking at this one. It happens to be chloride, which is a little different. That's not an oxyanion. It just happens to be chlorine gaining 1 electron. That's going to be 1 minus. And you kind of see where I do this 2 different ways. Sometimes I just leave it like that. Rarely, which I did in the first one, I'll put the little 1 in there. Okay, C. This one is one we just talked about. It is chlorate. That's the most common oxyanion for chlorine, and we'll say 1 minus. All right, D. We're looking at perchlorate. That is 1 additional oxygen. So not 3, but 1 additional, so it's 4. And again, these are just naming rules that you just have to memorize. E, hypochlorite. So just like we had the one for A, in which we had chlorite, this is going to be 1 less, given the name hypo. So not 2, but 1. And that's just, again, a naming rule. Right, 61 is done. Let's take a look at 67. Write the chemical formulas for the following compounds. Okay, so we have the names. This time we have to write down the formulas for these guys, but they're compounds, not these oxyanions. First one on here, it tells us that it is aluminum hydroxide. So we have to memorize that hydroxide is going to be -1. And the way I would go ahead and do this process here is I would say, okay, aluminum, got it, elemental symbol, and then hydroxide, and give a little space here. But now you have to be careful. Remember, aluminum is going to be a +3. It's always +3 when it's a cation. But we have to make sure that we include the entire hydroxide. Otherwise, that 3 applies only to hydrogen. It applies to the whole thing. So therefore, I put the 3 on the outside of the brackets. And then the 1 that comes from hydroxide, we just don't write that down. It's the fact you have aluminum there implies that you have 1. All right, let's do B, and I'll just write it below here. For this one, it tells us it's potassium sulfate, and I'll just write it over here, sulfate. You have to memorize that as well. SO4 2 minus, and if I write the name down for this one, it was potassium, which is a +1. It's a group 1, so it's always +1. And then I'm going to write the sulfate down. And remember that 2 that's up here from I had before. I'm going to swing that down to here, the crisscross method, which we talked about in the lecture. That 1 was up here. I don't need to worry about it. No brackets necessary. C. Looking at C, I have copper. It's kind of goofy how this one printed out. Copper 1 oxide. So the oxide is just going to be 2 minus because oxygen's in group 16. Jump over 2 spots, give it to 18, so 2 electrons, 2 minus. Copper is 1, so I'm just going to write this way, like copper, there's a +1, which I'm not going to write. Oxide was 2 minus, so I'm going to swing the 2 down here, from here down to here, and 1, I'm not going to write it. There it is, copper 1 oxide. D, what do we have for D? Zinc, zinc nitrate. Nitrate, another one that you will memorize, NO3, 1 minus. I will write the zinc, then I will write the nitrate. Nitrate is a 1, I'm not going to write it. Zinc is 2 plus, it's always 2 plus. So I need to write that down here, but I need to put the brackets on to show that I have 2 full nitrates. Done. Let's go over to E, and E is mercury 2 bromide. Mercury is Hg, it's 2, so 2 plus, just hold that thought. Bromide is a group 17, which is always going to be -1. Well, not always, but we'll hold on to that for now. It's -1. That 1 I'd write here, but I'm not going to. That 2 plus goes right there. F. F is iron 3 carbonate. So this one's kind of messy. Carbonate, you should memorize. Cl3, 2 minus. And then iron 3, so I know it's 3 plus. So let me just start this out. Iron, keep in mind there's a 3 plus, so I'm not going to write. Carbonate, I'll leave a little space. CO3. All right, that 3 is going to come down here, so I need my brackets. So I have 3 carbonates that came from the iron 3, swing it down. Carbonate was a 2 minus, that's sitting up here. Bring that down there. There it is. All right, last one on here. G, sodium hypobromite. Okay, so hypochlorite we had up here, and we know what that looked like. It looked like this. So not hypochlorite, but hypobromite look exactly the same, except instead of Cl, it's going to be Br. Sodium's easy. There it is. Sodium, Na, group 1, +1, don't worry about it. Hypobromite, same idea, same family, it acts the same, it looks the same. So BrO, 1 minus, don't worry about it. Sodium, don't worry about it. Done. All right, let's do the last problem in this list here for chapter 2. Give the name of the formula as appropriate for each of the following binary molecular substances. So the fact they're saying they're molecular, these are the ones where they're all on the right-hand side of the table plus hydrogen. They're going to have that whole di, tri, tetra, hexa, that kind of thing. Okay, let's start. For A, first one on here, A is SF6. So S, sulfur. And then I have 6 fluorides. So we have to remember that is hexa. And then we write out fluoride. Okay. B. B, it tells us, is IF5. So I only have 1 iodine. And it doesn't matter. Well, I guess it does. I'll deal with that when we get to an example. Iodine, and there's 5 fluorides. So that'll be pentafluoride. Okay, not too bad so far. Let's go with C. And for C, we have xenon and 3 oxygen. So xenon and 3 simply is trioxide. Not too bad so far. D, it gives us the name, and we have to write down what it is. Di is 2, so dinitrogen. And tetra is 4 oxides. Okay. E, hydrogen cyanide. Hydrogen, pretty easy. Cyanide is one of those Polyatomics you should memorize. We don't see it very often, but it exists. Cn1 minus, so that 1 goes down here. There it is. Last one on here, F, tetra, phosphorus, hexa, sulfide. Okay, so phosphorus is P, and there's tetra, so that's 4. And then hexasulfide, sulfide, hexa is 6. So those I think were a little bit easier probably than maybe these ionic ones that we did on the previous problem. But still, I don't think too bad. That is the end of chapter 2.